right, folks, so what I would like you to write up at the top of your page, your notes, is the mode of your calculator. This is really, really important if you are using one of mine. It's also important if your calculator dies or you have to put new batteries in it, because your calculator will always default to radian modes after it's been reset or after it dies. And my pre-calc kids are constantly going back and forth between the two modes. So if you're borrowing one of my calculators, this is very, very important. The mode needs to be in degrees, not radians. I'm going to show you. So not radians. So on your calculator, the mode button is right next to the second button. So right here, next to the second button, go ahead and click that. And you'll see that opens up all sorts of different specs. We're going to be looking at like that fourth item down, which has radians and degrees as an option. So you can see degree is highlighted on mine. If radians was highlighted, I would arrow over to degree, press enter, and once degree is highlighted, that's how I know that I am in the right mode. So I want everybody to make sure that their calculator is in degrees. Does anybody need a calculator?
Yo, how do I do that? Mode.
Mode, and then like fourth item down.
It switched my answer. Silent to read
And enter.
Now silent to read
Oh my gosh. It's 7 years ago.
What's horizontal?
That's really the only button that we mess around with. In pre-calc, sometimes we'll mess with like the polar versus function. But other than that, floating is how many decimal places you want to go. Math print works better than classic, so you can check your other settings, but those are typically the only ones that we mess around with. So folks, now that everyone is in degrees, we are ready to go to the next page because we will be using our calculator for some of the problems that follow. So first, on example 3 and 4, I want you to write that we are going to round to the hundredths. How many places past the decimal is the hundredths place? 2. So rounding is going to be a big part about this. And for these problems, I have come up with kind of a procedure in order to help you work through these. So step 1, let me find my pen, is start with the angle. And as you'll notice, that's kind of the same thing that we were saying on the previous page. Always start with the angle. Step number 2, after starting with the angle, is identify the side relationships. And that means hype, up, and edge. Hype, opposite, and adjacent. So that's exactly what we were doing with SOHCAHTOA on the previous page, starting with the angle, identifying the side relationships. So the only thing that's different is step 3 is we are going to decide on the trig function that we will use for solving. So decide on trig function using SO, CA, or TOA. So decide on trig function, SO, CA, or TOA. So the instructions for this is to completely solve each triangle in example 3 and example 4. To solve a triangle means to find all sides and angles. We'll say all angles and sides. So it's not marked, but it should be. I want you to draw this angle as a right angle on that triangle. And we're going to go ahead and label this as angle A, the side across from it as side A. This will be angle B. This will be side B, angle C, and side C. And again, you could just as easily have said that this was angle A and that was angle B, but just for us having the same variable labels, let's go ahead and label our diagram this way. But angle C has to be the right angle, and the side opposite from it has to be little c, or the hypotenuse. So folks, if I wanted to start by finding the missing angle A, what would I do to find that? So perfect. We're going to use the fact that there are 180 degrees in a triangle total. So if there's 180 degrees total, I can subtract the angles that I already have, 18 degrees and 90 degrees, to give me what angle A is. So using our calculators, or doing some mental math if your brain's there today, 180 minus 18 minus 90 is 72 degrees. And that's our unit for angles. And our first missing piece of the triangle. Now, I personally like to use the variable names when I'm solving, but I know some people like to just draw in what is missing on the diagram. So I'll accept either. Now, we have all three angles, but now we need to find the missing sides, B and C. Why doesn't Pythagorean theorem work for us here? We only have one side. One equation, two unknowns, that's not going to work out too well for us. So we can't use Pythagorean theorem, and I want you to write this so that you remember. So we can't use the Pythagorean theorem because only one known side. But this is where trig ratios come into play. Now, going up to those 3 steps that we wrote above, it says start with the angle. Which angle do you think we should use? 18 degrees or 72 degrees? The right angle is always off limits. Why is 18 maybe better to use than 72? Can anyone explain why that might be a better idea? Smaller number, and it was given to us. If we did something stupid in here and calculated something incorrectly, if I use a wrong answer to calculate more answers, it's just going to be errors layered on errors. Now, we know that the 72 degrees is correct, but just in case it wasn't, it's always best to use your given info as much as possible. So we're going to use the 18 degrees as my noted angle. And we are going to determine the side relationships of our given stuff. What is A relative to angle B? What is 100 meters? Is it opposite, adjacent, or hypotenuse? It's adjacent. So C is adjacent also, but C is our hypotenuse. So A is the adjacent side. Now, we want to always find the smallest side first. So we're going to write that as a feature with this as well. Solve for smallest side first. Why, Miss Cairo? This is a rule that comes into play in trig and pre-calc when you are solving non-right triangles, because your calculator only spits out acute angles, it's nothing that's really going to matter to us. So if you're like, oh my gosh, what if I don't solve for the small side first? It just means your answers are going to be a little bit off. They're not going to match up with what's on the answer key. So for consistency's sake on everything, we are always going to solve for the smallest side first. So who's smaller? B. How do we know? There's two ways that we know that it's smaller than C. What's one way? Yes. Perfect. Hypotenuse is always the longest side, so that means B is going to be shorter than C. What's another way we know? Yes?
The angle across from it is smaller.
Perfect. So, folks, if I think about the angle and the side across from it, or eating that side, as I open this mouth wider, the side across from it gets larger. So 72 is a large angle, and as you can see, that opposite side is fairly large. 18 is a smaller angle, and that side across from it is smaller. So smallest angle has the smallest opposite side. Largest angle has the largest opposite side. And that is why the 90-degree angle is across from the hypotenuse. So we're going to find B first and C second. And we'll resume with that after lunch.